Hello, welcome to Chapter 7, which will deal with similarity. The first section is on ratios and proportions. So what is a ratio? Well, it's a comparison of two different things. So for example, here, boys to girls in the classroom. If we had 12 girls, 13 boys, it would be 12 to 13. Freshmen to seniors in a school. Wingspan to height of either, humans that stand with their hands stretched out versus compared to their height. There are three different ways that you could represent a ratio. The first one is a fraction. So for example, 2/3. And you should always simplify it and it should be in the same units. You could separate the two values with a colon. So 2.3 is also a way to show a ratio. And then the last way is to actually use the word 2 between the two numbers that you're comparing. So you'd write 2 to 3. But the way you would say these out loud is all the same. All right, so let's get into some examples here. The first example says the perimeter of a rectangle is 60 centimeters. The ratio of the length and the width is 3 to 2. Find the area of the rectangle. So the first thing I notice is the length to width, that ratio, that's 3 to 2. Length to width. I know the length is not 3 and the width is not 2 because that would not give me a perimeter of 60, right? Because perimeter is adding up all the sides. You do length times or plus length plus width, or 2L plus 2W. So here, this is the length and width once they were both reduced by some value. So the way I like to do these problems, I like to draw myself a little rectangle, and I know here this is a 3 to 2 ratio. I know the perimeter is 60. So again, like I said, I know that the length isn't 3, the width isn't 2. They were reduced. What were they reduced by? I don't know. We're going to find out, and how I find out what that value is, it was x and x. Because now if I write that ratio, 3x to 2x, the x's will cancel. So what we're going to do is set up our perimeter formula. Perimeter is 2L plus 2W, or like I said, you could add the four sides together. We know the perimeter, it's 60, is going to equal 2 times 3x, our length, plus 2 times 2x, our width. All right, so cleaning this up, we're going to get 60 equals 6x plus 4x. I'm going to just have to bring this down here because I'm running out of room. 60 is going to equal 6x plus 4x, which is 10x. Divide both sides by 10. And I get 6 is x. So what I should do now is take this value and plug it in here. The length to width was 3x to 2x, really. So the length is going to be 3 times 6. So here we have 18. The width is 2 times 6, so 12. All right, hopefully everybody knows that the area of a rectangle is its length times its width. So if I do 18 times 12, I get an area of 216. My units here are centimeters squared. One last thing, if you know that the length is 18 and the width is 12, I would suggest quickly just take your calculator and see, would you get a perimeter of 60? If you did 18 plus 18 plus 12 plus 12, is that a perimeter of 60? It is, so then you know that you found the correct value for x. All right, the next problem on this page is also a very popular type of problem from this chapter, in this section specifically. It says the ratio of the angles in a triangle is 2 to 3 to 5. Find the measure of the angle. So when we're comparing three numbers like this is what's called an extended ratio because it's more than just a comparison of two. Now we have three numbers. So what I like to do is I do like to draw a triangle, and it doesn't have to be accurate. It's just a sketch for myself. And I know that the angles are 2 to 3 to 5. Just like in the previous problem, I know these angles aren't 2 degrees, 3 degrees, and 5 degrees. They were reduced by something. We write a ratio in reduced form. These three angles would not add up to 180. So what were they reduced by? We don't know. So when we don't know something in math, we usually just call it x. Okay, so now that I have these angles written in terms of x, I write my equation. I know that if I take 5x plus 2x plus 3x, I am going to get 180. Because this is a triangle, triangle sum theorem says the angles always add up to 180. Okay, so I get 10x equals 180. X is going to equal 18. So the angles then are 2 times 18. Then the second angle is 3 times 18. And the third angle is 5 times 18. 2 times 18 is 36. 2, 54, 2, 90. These three angles, if I did this correctly, these three angles must add up to 180. So I could quickly add them together, see if they do. If they add up to 180, I'm good. If they add up to anything else, I probably made a mistake somewhere. Okay, next thing we're going to talk about is proportions. What is a proportion? It's a comparison of ratios. So basically, what I always tell students, it's a fraction equal to a fraction. So a proportion is an equation. You're going to have a fraction that's equal to another fraction, which we've done quite a bit of them this year, so this shouldn't be anything new. So here are examples of proportions. If 7 pencils cost 25 cents, how much will 400,000 pencils cost? 10 boys and 11 girls. How many boys would be in the school if there are 850 girls? So I'm actually going to set these up for us here. When I set up a proportion, so if I do 7 pencils to 25 cents, I have to follow that same pattern on the right side. So number of pencils over the cost. I can't flip that. However, I could have written cost over pencils. But then on the right side, I have to write cost over pencils. So here we have 400,000 over X. When you have a proportion, we cross multiply. So we're going to get 7X equals 100,000, right? Because 0.25 is the same thing as a fourth of 400,000. And now we're going to divide that by 7. And it would cost us $14,285.72 to get 400,000 pencils. Wow. Okay, next one. So here we have boys and girls. And I usually like to, if the problem mentions boys then girls, that's how I set up my proportion also. So 10 boys to 11 girls. How many boys would be in the school if there were 850 girls? So that's going to go in the denominator. Now, sometimes you have to be careful because it'll say how many total students there are for the second part, in which case your first denominator, you'd have to find the total of your little sample that you're looking at. All right, let's use little b. So 11b equals 8,500, right? If I cross multiply, let me show that. Cross multiplication. Okay, so now 8,500 divided by 11, we get a decimal. It should be about, we're going to round up, 773 boys. A moose can be very deadly. It's true. I've seen some shows where, like in Alaska, the police has to come because there's a moose in someone's front lawn. Scary stuff. All right, so more about proportions. When you have A over B equals C over D, then A and D are called the extremes. B and C are called the means. Two things are said to be proportional if the proportion is true. So here again, it just goes through that the product of the extremes is equal to the product of the mean. So that's just cross multiplying, right? This fraction looks a little strange the way it's written horizontally, but that's just what we did even on the previous page. I went and I multiplied. I cross multiplied AD, that's where we get here, equals BC. That's what you get on this side. So that's known as cross multiplying. We have done plenty of that this year. So what this slide is talking about is the reciprocal property. If you have two ratios that are true, then their reciprocals will also be true. So notice that my first fraction here got flipped, right? A over B becomes B over A. But then in order to keep that true, the second one also you have to flip it. You also have to have the reciprocal. So just like with the pencils, I said as long as if we switched it and had cost over number of pencils, that's okay, but we have to do that to both sides. Okay, so in other words, flipping both sides is cool. It's fine. You could do that. Oh, spoiler alert. So these examples, actually, we already did them on the other page. And yeah, so notice how the answer here, you get 772.73 boys. You can't have a part of a person. Everybody is a full person. And so you would have had to round that number up to 773 boys. All right, so the last problem here is a proportion where we're going to solve for y. So because it's a proportion, we can cross multiply. I'm going to take and multiply 3 times y. I get 3y equals, now here's where you have to be careful. Because your denominator here has 2 terms, the y plus 2, when you multiply by 2, it's not just 2y plus 2. It's 2 times that entire quantity, y plus 2. Be careful with that. I would say that's probably the biggest mistake that kids make is they rush through a problem like this and forget to distribute. All right, so let's go ahead and distribute this. 3y is going to equal 2y plus 4. We're going to subtract 2y from both sides, giving us y on the left side equals 4. The nice thing about proportions, you can always check your answers by plugging back in. If I have 3 over, now I got 4 for y plus 2, does this equal 2 over 4? So at first glance, it may appear that these aren't equal, but 3 over 4 plus 2 is 6. Does this equal 2/4? Again, they don't really look the same, but if we reduce these fractions, we get a half equals a half. Okay? Or even you could check their cross products. 3 times 4 does equal 6 times 2, so that works out. We know that it's correct, and we can move along with confidence and do the next problem. All right, that is it for these notes. Tonight, do your day 1 homework that's on the assignment sheet on Schoology, and we'll do section 7.2 next time. Thank you so much for watching. Have a great day. Bye.